Today we shall study about magnetostatics. In the magnetostatics, we study about inverse square law. The force between two poles varies directly as the product of their pole strength and inversely as the square of the distance between them. This law was first discovered by Coulomb and it is called the inverse square law. So, F proportional mm dash and F proportional 1 by r square. इसलिए F proportional mm dash बटा r square बराबर k mm dash बटा r square, where m is the pole strength of one north pole and m dash is the pole strength of south pole, and the r is the distance between two poles and k is the constant. So, in the CGS system, k बराबर mu naught mu and F बराबर mu naught mu mm dash बटा r square times, where mu is a constant depending upon the nature of the intervening medium and is called the permeability relative to free space of absolute permeability mu naught of the medium. The force is measured in dynes, the pole strength in EMU, it means electromagnetic unit, and the distance in centimeter, while mu naught for vacuum is unity. On the rationalized MK system, k बराबर mu naught mu बटा 4 pi and the Coulomb's law becomes F बराबर mu naught mu बटा 4 pi mm dash बटा r square newtons, where mu naught is the permeability of free space or vacuum. Mu naught बराबर 4 pi गुना 10⁻⁷ Henry per meter. The pole strength is measured in Newton per Tesla, the distance in meters and the force in newtons. The product mu naught बराबर mu a is called the absolute permeability of the medium, so that the relative permeability mu बराबर mu a बटा mu naught. In air or strictly speaking, in vacuum mu बराबर 1 in CGS system, and equation 1 reduces to F बराबर mm dash बटा r square. Now unit pole, if we make m बराबर m dash, mu बराबर 1, r बराबर 1, in equation 1 we have m square बराबर 1, so m बराबर plus minus 1. Hence, the unit pole is that pole which, when placed at a distance of 1 centimeter in air or preferably vacuum from an equal and similar pole, repels it with a force of 1 dyne. The pole strength is expressed in unit poles. The unit of magnetic pole strength has no special name. It forms the basis of a system of electrical units referred to as the electromagnetic system. On the rationalized MK system, the Coulomb law of force is F बराबर mu naught mu बटा 4 pi into mm dash बटा r square. The unit pole on this system is Newton per Tesla, or 1 Newton per Tesla बराबर 10 CGS unit poles in EMU बराबर 3 गुना 10 to the power 11 unit poles in ESU. ESU means electrostatic unit. The force between two unit poles of 1 Newton per Tesla is, when placed in 1 meter apart in vacuum, is 10 to the power minus 7 Newton and not 1 Newton. Magnetic field and field intensity, any region surrounding a magnet in which its magnetic effect may be detected is referred to as its magnetic field. The distance at which such effects may be detected is great, but because of the operation of Coulomb's inverse square law, the practical extent of the field is quite limited. The intensity of the magnetic field at any point in a magnetic field is a force in dynes experienced by a unit north pole placed at that point it is usually represented by the letter H, capital H. F barabar m dash h. Its unit is dynes per unit pole or oster. Previously the term Gauss was also used for it, but that term now is exclusively used for the unit of magnetic induction per unit area or flux density B. So F बराबर m dash बटा r square बराबर m dash h. इसलिए h बराबर f बटा m dash बराबर m बटा r square बराबर 4 pi m बटा 4 pi r square oster. Now if a unit pole gives rise to 4 pi unit tubes of force, then field intensity is measured as the number of unit tubes per square centimeter. A field of unit intensity 1 oster बराबर 1 tube per unit area. On the rationalized MK system, the unit of magnetic field intensity is ampere meter and is 4 pi × 10 to the power minus a oster. The unit of flux density B or mu H in CGS EMU is Gauss and the rationalized MK unit is Weber per meter square or Tesla. 1 Weber per meter square is equal to 10 to the power 4 Gauss. The flux density B plays the same part on a moving charge that electric intensity E plays on a stationary charge, and hence the two are corresponding quantities. So F बराबर QE and F बराबर QB cross B.